So in this video, we're going to be discussing how much does a jump move the Earth/world, and this would be halfway between your jump when you are the farthest from the Earth, which is when gravity starts to win and the planet and you are pulled back together. So to find this, it's the max change would be initial velocity multiplied by time in the air divided by 2 plus 1/2 gravitational pull multiplied by time in air divided by 2 squared. And then here I'm just rewriting the equation to make it cleaner, and then I'm writing the units more specifically on what they need to be, such as this initial velocity needing to be Earth's initial velocity when you jump off of it, because you do move Earth when you jump off of it. And then the g would be Earth's gravitational acceleration to you, so it's not going to be negative 9.8 like it is for you on Earth. And then how we find Earth's initial velocity, we can use the conservation of momentum to do this, which is momentum is mass times velocity. So my momentum would be equal to the Earth's momentum. So taking my mass multiplied by initial velocity for me, which to find initial velocity you can multiply Earth's gravity times time in air divided by 2. So mass times the gravity times time in air divided by 2 divided by Earth's mass. Moving the equation around would allow us to find Earth's initial velocity. So now that we know how to find Earth's initial velocity, we can plug that in. And I put the negative by the g because that value of gravity will be a -1. Since it is pulling down, we assume that's negative. So replacing initial velocity with what we found, the equation we found to find initial velocity, we then need to find Earth's acceleration to you, also known as its gravitational pull to you. And there's an equation to do this, or we can do this an easier way, because Earth's net force is equal in magnitude to my net force I feel in the air, except in opposite directions. Meaning that Earth's net force to me when I'm in the air will be a positive value while mine is negative, which is why Earth and I are brought together when I jump. So to find my normal force, which actually Earth's net force is equal to, would be mass times the gravitational pull, but positively. So then actually dividing out Earth's mass would give us the gravitational pull Earth feels to me while I am in the air. So then plugging this in to the equation and writing it out, we then seem to get closer to an answer on how much Earth has moved the maximum displacement. So then just writing it out cleaner, multiplying the time divided by 2 in for that, I get t squared over 4 in the first part. And then in the second part, that t divided by 2 squared was changed into t squared divided by 8 because I had to divide by 2. And then taking that divided by 8 and that divided by 4, I changed it so it looks cleaner. So the whole thing at the top would be multiplied by 0.25, and then the other one would be multiplied by 0.125. And when adding these values together, we get max displacement equals 0.125 multiplied by your mass multiplied by your acceleration on Earth, aka gravity, times time squared, all over Earth's mass. So then actually writing this equation and putting in the correct numerical values, I can then calculate what my max, how far I move Earth when I jump, which is a very small number, negative 9.0478106 times 10 to the negative 24th meters, which is basically 0, which explains why when people jump you don't see the Earth wobble or feel the Earth wobble. And that is the end of the video, and thank you.